Hi, welcome to Lab Fluid Mechanic. I'm Dr. Hidayat will explain to you the instruction to conduct the experiment as well as preparing the lab report. So today, as you can see, we have the lab sheet in the screen for the flow in pipe. Alright, so the titles of today's experiment, flow in pipe, and the objective is to study the flow of air in the pipe with the considerations of Reynolds number, power law velocity profile of turbulent flow, local velocity profile, and calculations of shear stress at the pipe wall. The apparatus that we're going to use is the pipe flow system unit. Here is the theoretical backgrounds of the experiment. We have a very long pipe having 76 millimeter internal diameter. Alright, and then we have the centrifugal pump is used to suck the air through a nozzle. The adjustable pitot static tube is installed at the location far from the nozzle. The static pressure along the pipe is obtained by installing a pressure tapping at a certain location from the nozzle. For example, this is a very long pipe, and then we have the nozzle, and then we have the centrifugal pump. Along the pipe, we install the tapping. Here, as mentioned, as a static pressure. We measure every static pressure along the pipe. Alright, by installing the pressure tapping here at a certain location from the nozzle. Later on, we will specify the distance from the nozzle. The pressure reading is obtained by connecting the pressure tapping and the adjustable pitot static tube to the water or air manometer. Alright, we combine both air and manometer to ease the theoretical calculations. Next, here is the formula is very important for you to do the experiment as well as to calculate and place the value inside the table. Alright, here is the air kinematic viscosity used in this experiment is given as this is mu. Alright, the symbol of mu. Infinity is the symbol of air symbol. Alright, mu air over mu naught. Naught is the value taken at NTP condition, which is normal temperature and pressure condition, equal to P naught over P multiply with bracket T over 288 the power of 7 over 4. Right? And B is the air density for the experiment is, alright, the density rho infinity, which is rho of air, equal to P over RT. This equation is the ideal gas equation where we're going to use the gas constant equal to 287 joule per kilogram Kelvin, and the temperature definitely we're going to use the Kelvin, which is absolute temperature as well as absolute pressure. Here P is atmospheric pressure. So the value of rho naught and the mu, the value of rho infinity, which is rho of air, and the mu of air gonna be used in the table. You can see in the table, we're gonna use those value and then place it here and place it here. Alright, this is the temperature at the room condition we will give to you later on, as you can see in this example 28. Alright, and then the atmospheric pressure as well we will give you in this value. So next is the static pressure. This is referred directly to the table 1, where you can see in table 1, this is table 1, we have 14 numbers of reading. Start with 25, 10 the power of negative 3 meter until 6130 millimeter. Alright, this is the water static column. This data will be given to you. Alright, the one that you need to calculate is the pressure based on this reading. Alright, this is data that will give to you later on. So, how to calculate on this pressure, static pressure at the certain location? You can see here the formula is P equal to rho of water multiplied with gravity multiplied with the change of height elevations of water here that we're going to give you, right? Later on, and then the air velocity in the boundary layer region we call as the U infinity. This is as the local air velocity at a certain location. So, in this part, the difference in the dynamic and the static pressure at each of the pitot static tube location is given by the water air manometer as follow. Here, the delta H of water equal to negative H, negative delta H15 minus H14. So, negative means we need to counter it because this value gonna get negative. Multiply with negative will get positive because we consider most on the magnitude only. Alright, here in order to calculate the air velocity, we use this formula. The air velocity is velocity of air equal to the square root of 2g delta H of air. However, we don't have the delta H of air. We only have the delta H of water, as you can see in the table here. Table number 2. Thus, we need to do some adjustments. So, based on these relations, air and water having the same pressure, rho of air GH, rho of water GH of water, and therefore we make the H, delta H of air, we move this part to the right side, become division, and then we substitute back into equation 5, leading to equation 7, which is the local air velocity equal to square root of 2g delta 2g multiplied with rho of water over rho of air multiplied with delta H of water. And here you need to fill in this table, alright, in this column. Next is you need to find the average velocity. In order to get the average velocity, you need to find the flow rate of air in the pipe, which is Q, over the pipe cross-sectional area. So since the pipe is in the circular cross-sectional area, you're going to use circle formula, which is pi r squared or pi d squared over 4. So, the area U definitely will be easier for you to find. However, for the Q, alright, based on this definition, the flow rate equal to 2 pi integration of 0 to r U multiplied with r minus y, change of y, where y is the adjustable pitot static tube height from the pipe wall, and U is local velocity with respect to y, and R is the total radius of the pipe. Alright, so based on this part, you can see integration of this U multiplied with R minus y, the change of y, is the area under the URY versus Y graph. This part you need to plot the graph. Once you plot the graph, you need to calculate the area under the graph that will get this value. This value you gonna replace with this value. You can see here, just multiply with 2 pi. Once the area here multiply with 2 pi, you gonna get the Q. The Q you substitute back into this equation number 8. The flow rate of air divide with the area, then you will get the average velocity. And here, the exponent n in the turbulent flow velocity profile that you gonna require to get this equation, you require to get the power law, which is n. This is basic of formula. Once you do the ln both sides, you gonna realize that this part is actually relate to your table. Alright, so let me show you. Okay, now you can see we have ln y over r versus ln u over u. Capital U is U maximum. Alright, the U maximum is taken from the last reading here. Remember, U maximum is taken from the last reading, which is y increment 39. This refer to U max. You calculate here, U is actually U max. So once you do the graph, ln y versus y over r versus ln u over u max, the slope of the graph is n. Alright, so you need to calculate the slope. That slope refer to the power law, which is n here. How it is captured? It is captured from this part. You try to do ln this part and ln this part, and then you move 1 over n to the other side. It will become the gradient. Alright, this gradient you need to calculate on your own. Then you will find the n. You try to do the lns here. Ln and ln both sides. You move the other side. It will become ln u over u max equal to 1 over n ln y over r. So from here, I hope that you understand how it formed. So the Reynolds number given here is Reynolds number multiplied with 2r radius, total radius, multiplied with average air velocity over dynamic viscosity of air. This one you have calculated before. And lastly, the pipe wall shear stress is given by tau wall radius over 2 multiplied with delta P over delta X. So how to get delta P over delta X? It is from your, this one, the plot D. You need to plot the static pressure P versus the distance from the nozzle. Alright, P versus X. This one. P versus X, and then you will find that the slope is actually delta P over delta X that you're going to use in this calculation to get the tau wall. Here is the methodology. The first, at the specific centrifugal pump speed, allow the flow to be steady before the pressure reading is taken. B. Record the static pressure data and fill in the table 1. C. Lower down the adjustable pitot static tube until it touches the pipe wall. Record the dynamic pressure, the last reading, P15. Record the data from the adjustable pitot static tube for the increments of 1 mm until the 5th readings only. For the 6th reading and beyond, take the increments of 2 mm until the pitot static tube exceed the pipe center line. And lastly, record the atmospheric pressure and the temperature. So let's take a look of the video prepared by our lab assistant engineer.
Press 1. Next, we go to the table of experiment data. That one is the last page. So for the last page, we have atmosphere pressure, air viscosity, temperature, and air density. So we also have table 1 and table 2. Okay, so for the first one, we will go to the table 1. Okay, so next we go to the table 1. Okay, so for the water static column for the table 1, start from number 1 until 14. So you need to find water static column. So water static column, you start from number 1 here until 14. Example, number 1 minus with here, this one is water static column. So number 2 minus with the water static column again. Number 3 minus with the water static column until the last reading is 14. So 14 minus with water static column. Then you will get H water here. H water number 1 until 14 for water static column. Then you need to find pressure. That one is PS by using the calculation. So for the table 2, we will find Y increment. So Y increment we will find by using the pitot static tube. So here is the pitot static tube. This one. Okay, so for the first one, we need to adjust the pitot static tube at 0 here, or we call it as we reset the pitot static tube 0. Okay, next, you need to record the data for the adjustable pitot static tube for increment 1 mm until 5 reading. So this one is 1 mm. Just rotate this pitot static tube until 10. 10 here is equal to 1 mm. So you need to write down here 1 mm. Okay, after you set at the pitot static tube 1 mm, you need to get reading for 15 minus with 14. That one you need to fill at the pitot adjustment pitot static tube reading H water. So the reading for H water is H15 minus with H14. Alright, after 1 mm, rotate it again until we get 2 mm. So 0 here means 2 mm. So after you set at 2 mm, take again for H water, H15 minus with H14. The reading you get minus here. So then you put to the H water for the second reading. So for the next 3 mm, you need to repeat until 5 mm. So each increment is 1 mm. For the 6th reading, okay, you need to increase increment at 2 mm. So 2 mm means you need to rotate it for the full rotation. Alright, if you start with 10 here, so you need to go again at 10. So means that one is the 2 mm. m. That is for the 6th reading, or you will put here at 7 mm for the 6th reading. 1, 2, 3, 4, 5. Alright, so number 6 here, you must put at 7 mm. Alright, so after you set at 7 mm, alright, here at 7 mm, so you need to take again H15 minus with H14. So this one is the repetition step. Okay, so for increment 2 mm that you get it, so you must take until the pitot static tube here is exceed the pipe center line. So the diameter of this pipe is 76 mm. So you need to take the last reading, that one is 39 mm, because that one is the exceed the pipe center line.
Now you have seen how the methodology works when you set up the experiment. Alright, now we go to the result where you need to plot the graph U R minus Y versus Y. Alright, this is where you got from the from your calculation. I believe I have explained to you. U, velocity R minus Y, you have to plot another column in this graph. In this part, U multiply with R minus 1, another column. In order to plot this part A, U multiply with R minus Y versus Y. Okay, versus this, another column. And then ln Y over R versus ln U over U max, another column. You need to create another column. That column, alright, column number 2 and 3, the additional 2 and 3 column, just for this one, ln this one and ln this one, in order for you to tabulate the graph for part B. So this part you're gonna get the slope is the power law n. And C, you need to plot the velocity U, the local velocity, versus the adjustable pitot static tube Y. So here you need to plot U versus Y, and then you will find that this will require to get the velocity profile. Okay. And the static pressure, PS versus distance. So you need to plot this one with this one, right? So why you need to plot this one? Because you need to get the slope of the graph, which is delta P over delta X. That require to calculate the shear stress here. Okay. And discuss the experiment conducted by considering the calculated variable that you have calculated before this. In this part, you calculate this one, you calculate this one. What you need to explain about the Reynolds number. It is the turbulent or laminar flow. And then you need to explain in detail. Conclusion. State the conclusion that can be made from the experiment. Right? So the table here will be given to you. Alright. The data, the raw data, we will only give you the raw data for water static column and the adjustable pitot static tube reading, as you can see in this part. Alright. For the lab report submission, please compile this together. The cover note for the lab sheets. This is for the short report. Please fill out your detail, title, your name, the date of experiment, and myself. Alright, Dr. Muhammad Nur Hidayat. And this part, alright, just this one, just leave it here, and make sure during your report or before doing a report, you need to understand the rubric. This is how you need to score your lab sheet report. So please read through the how to score the data collection. Alright, in the short report, you need to do the data collection, analysis, interpretations, conclusion. That's it. So you realize that the analysis and interpretation carry heavy weightage, which is 60%. And in order for you to score high, you need to complete the analysis with good supporting evidence. Please support from any other literature review, any researcher or scientist that mention the same as your experiment, your findings. Discuss the finding in the relation to theory. Alright, so the data collection, complete data gathering. We give you the raw data and then you need to calculate and put it inside the table column. And make sure your conclusion, well-supported conclusion based on the finding. Alright, and this conclusion relate back to the objective of the experiment. Alright, for those gonna do the formal reports, please follow this rubric instruction, and please make sure that you compile together the cover note for lab sheets of formal report. First, as usual, fill up your detail, title, your name, date of experiment, lecture name, Dr. Muhammad Nur Hidayat, and then for this one, leave it blank. And for the formal report, you need to include the introduction, objective, data collection, analysis, interpretation, conclusion, references, organization and clarity, and time submitted. Alright, please read through the rubric score on how to score high. So in order to score outstanding, for the introduction, please provide concise lead into the report. And for the objective, well written the background. And for the data collections, alright, we give you all the raw data. You need to calculate on your own self and then place it in a table. Alright, data gathered, properly presented in the table, graph. Please properly caption your table or your graph. For example, table 1 refer to, table 2 refer to what. And as well as the discussion part, please complete the analysis with good supporting evidence. The conclusion, well-supported conclusion based on your finding. Alright, your conclusion, please make sure go back to the objective. Answer the objective. The references, highly related references, please use the proper formats. If you use the APA, please use consistently. Alright, and organization and clarity, proper language, smooth flow, grammatical correct, clean, neatly bound in report cover. And lastly, time submitted. Please submit on time. Right? So therefore, I think that's all for today's session. Thank you very much for your watching. Bye.